I think we should practice some Chapter 5 application problems. There's 3 different types we're going to focus on today. The first is the rate of work problem. So let's see what we got here. A copy machine can copy a report in 30 minutes. When a second copy machine is used at the same time, the copying can be done in 18 minutes. How long would it take the second copy machine to do the copying alone? So here's what we got. We're going to say like machine 1, we're adding in machines 2 rate, and that's going to be both of them. Now, machine 1 can get it done in 30 minutes. So technically, every minute, it's doing 1/30th of the job. So we're going to set that up as our first fraction, 1 over 30. It's always going to be like 1 over how long it takes. Now, we don't know how long it's going to take machine 2 to do it, but we know it'll be 1 over however long it does. And again, we don't know that. So we could just say 1 over x, and then together, it takes them 18 minutes. So every minute they're doing 1/18th of the job. So again, it's always just 1 over whatever the length of time is, whatever the rate is. Now we're going to multiply here and clear out these fractions. We're going to use a common multiple. Now you could find the smallest number that 30 and 18 go into, or what I think is easier is just like include all the denominators. So we're going to multiply by 30 times x times 18. And when you do that here, every one is going to have something in the denominator that cancels. So if we did that to this first one, you'd have 30 times x times 18 over 30 plus 30 times x times 18 over x equals 30 times x times 18 over 18. And again, every one of these is going to have something that cancels out. So if you want in the future, you can kind of skip writing this step and just multiply the numerator by whatever wouldn't get canceled out. Like on this first one, the 30s are going to cancel out. So you have x times 18, which is 18x. The second fraction, the x's will cancel out, so you have 30 times 18. I know that 3 times 18 is 54, so this will be 540. And this last one, the 18s will cancel out, so you have 30 times x, 30x. Now again, that's not the least common multiple. There's a smaller number than 540 that 30 and 18 go into. 90? We could have used 90x, and that would have cleared the fractions too, but this requires less thinking. So now if you look, 18x plus 540 equals 30x. We could subtract the 18x from both sides, which gives us 540 equals 12x, and then we'll divide that by 12. X equals, let's see, 540 divided by 12, 45. And this was 45 minutes. It's how long it would take that second copy machine to do the job all by itself. Pretty common setup. Let's try another one. But this one has a bit of a curveball to it. An empty oil tank can be filled by a pipeline in 10 hours. So that's going to be one of our fractions, 1 over 10. The tank can be emptied in 20 hours by opening a valve. If the valve is opened while it's filling the tank, how long will it take for the tank to fill? So here's the difference. So we have like filling, emptying, and then full. But this one, it's emptying at the same time. So on the first one, we were like adding the 2 chunks, because it was like the rate 1 plus rate 2 equals like, let's work together. This one, they're opening the valve. I don't know why, they're sabotaging me. I'm trying to fill the tank, man. So I'm filling the tank in 10 hours. So we're gonna say 1 over 10. It's emptying out. So we're gonna subtract the rate that it's emptying. And it says it empties out in 20 hours. And we want to know, well, if both of those things are happening, how long is it going to take? So we don't know this rate, so we'll say 1 over x. Now we're going to multiply again by a common denominator. Now 10 goes into 20, so we could just multiply by 20x and there won't be any fractions. However, let's kind of just get used to this process of we can always just multiply by all the denominators. So here, the 10s are going to cancel out. So we're just going to have 20x times 1, which is 20x, minus. Here the 20s will cancel out, so we're going to have 10x times 1, that's 10x. And then here the x's would cancel out, so it's just going to be 10 times 20, which is 200. There's our new equation, and that's a pretty easy equation to solve. So 20x minus 10x is 10x equals 200, and then we would divide by 10. X equals 20 hours. Nice. That was fun. Let's see what else we got. The next type of problems we have are these distance, rate, and time problems. Now there's a formula that distance equals rate times time. That's a pretty important formula, and I found that the best way to solve these for me is to kind of set up a chart like this. So a car travels 300 miles in the same time that a freight train travels 200 miles. The speed of the car is 20 miles an hour faster than the speed of the train. Find the speed of the car and the speed of the train. They're telling us to figure out the speed. Speed is our unknown. So let's look at some of the information. The car traveled 300 miles. So the car's distance was 300. The same time that a freight train traveled 200 miles, all right? Train went 200 miles. The other information they give us is the speed of the car is 20 miles an hour faster than the speed of the train. We don't know how fast the train's going. Let's call it x. But I know that the car's going 20 over that, so we could say the car's rate is x plus 20. The time, it doesn't say anything about the time, really. But check this out. If we have the formula distance equals rate times time, and we're getting time by itself, you would divide by the rate. So time is going to equal the distance divided by the rate. So if we were doing that for this chart, the car's distance, 300, divided by the car's rate, x plus 20. The train's distance, 200, divided by the train's rate. Why would we do that? Here's why. It says that they travel in the same time, meaning their two times are going to equal each other. So that's our equation. We're going to say the car's time, 300 over x plus 20, is equal to the train's time, 200 over x. Now, you have a fraction equals a fraction. This is where we can cross multiply and solve. So if I did 300 times x, that's 300x. If I'm doing 200 times x plus 20, you could set it up like a distribution problem if you'd like. Or you could just go ahead and multiply the 200 times each of them, which is what we're going to do now. That would give us 200x plus 4,000. Now you know how to solve linear equations. You would subtract the 200x there. So we'd have 100x equals 4,000, and then you would divide by 100, and you would get x equals 40. No, that doesn't answer our question. It says how fast was the car going and how fast was the train going. So the train speed is equal to x. So x is 40. The car speed is x, 40, plus 20. It's going 20 miles an hour faster, which means the car is going 60 miles per hour, and the train is going 40 miles per hour. Great. Now, how could you check that? You could say, all right, well, let's see, they covered 300 miles, and it was going 60 miles per hour, so the car did 300 miles divided by 60 miles per hour. So that would mean the car was traveling for 5 hours. If we did that with the train covered 200 miles going 40 miles per hour. So that means the train was also going for 5 hours. That's a way you could check it if you had some extra time on a quiz or a test. At 9 o'clock, Petunia set out from her house for a picnic. traveling at 15 miles per hour on her bike. Hey, we know Petunia's rate is 15. It's a little warm. Her brother left 15 minutes later and traveled at a speed of 30 miles per hour. All right, her brother's rate is 30. Cool, cool, cool. Nice. If both of them arrived at the picnic at the same time, how far did each travel? All right. So time, we don't really know. But let's say Petunia, let's call her unknown X. Now her brother was, let's say X hours, because we're giving it in miles per hour. Her brother left 15 minutes later. So what fraction of an hour is 15 minutes? That's 1/4 of an hour. So he's driving the exact amount of time minus 1/4 of an hour. So we'll say X minus 1/4. Right? See, amount of hours minus 1/4 of an hour. Now you could change that into a quarter, 0.25 if you want to, whatever helps. And then here for the distance, we don't know. But we know that distance equals rate times time. So if we just took the rate, Petunia's rate was 15, her time was X. If we just multiply those together, it'd be 15X. Same thing with her brother. We're going to do 30 times X minus 1/4. Or if you want, it might be easier to just change it into 0.25 because he drove for 1/4 less of an hour than Petunia did. Both of them arrived at the picnic at the same time. So if you look, like they're both going from their house to the picnic, the same exact distance. So that's important. Their distances are going to equal each other. So setting up an equation here, we'll say Petunia's distance, 15x, is equal to her brother's distance, 30 times x minus 0.25. There's our equation. Once you're set up, it's not too bad. So we'll go ahead and distribute that 30 here. So that would give us 30x minus 30 times 0.25. 1/4 of 30 would be 7.5. Great. Now we got to get the x's on the same side of the equal sign. So I would subtract the 30x onto the other side. But what do I know? But we're going to do that. So if we subtract 30x, we get negative 15x equals negative 7.5. And then all we have to do is divide by that negative 15. When we do that, we'll get x equals 0.5. What does that mean here? It says how far did each of them travel. Remember, they both traveled the same amount. The x is the amount of time they traveled. So if we want to check, we could say Petunia, her distance was 15 times x. So 15 times 0.5 means that she traveled 7.5 miles. That should be the distance for both of them. They both traveled the same amount of distance. Now if we check her brother, let's see. He was 30 times 0.5 minus 0.25. Now, 50 cents minus a quarter is a quarter. And if you did 30 times 0.25, it also comes out to 7.5 miles. So again, there are ways to check your answers. Make sure it makes sense. They both traveled 7.5 miles. Their distance should be equal because they both left from the same place and went to the same place. So that's problem type 2. Now we have to do the third type of problem. Ooh, the mixture problems. Whoa, okay. A chemist needs to make 1,000 milliliters of a 30% alcohol solution by mixing 25% and 55% solutions. Approximately how much of each should she use? So here's the chart that I create that I think is very helpful for these. You have the amount of each, the percentage of each, and then you have the amount times the percentage. Now you could convert the percentages into decimal forms if you'd like, But honestly, you don't even need to. You could just leave them like 50%. You could just leave as 50. Or you can make it 0.50 or 0.5. It's up to you, but just stay consistent with how you do it. So if we look, it says they need to make 1,000 milliliters altogether. So their blend is going to be 1,000 milliliters. We don't know how much of each of them, but let's say the first mixture, we're calling it X. So what would we write for the second mixture? Let's say we use 200 milliliters of the first one. How much would we use of the second one if it's 1,000 total? It'd be 800, right? Because you could do 1,000 minus 200. Now I made up the 200, but mix 2 is going to be 1,000 minus X, the amount of mixture 1 that we use. That's the doozy. That was the tricky part here. Don't worry, it gets better. All right, let's fill in our percentages here. The 1,000 milliliters is 30%. And then the other two, it says 25 and 55. So it doesn't matter which one you put here. Let's put our 25% here, and we'll put our 55% here. And honestly, it doesn't matter as long as you just remember, like when you're answering the question, because it says like how much of each, you would just have to make sure that you're saying blah, blah, blah of the 25% mixture and blah, blah, blah of the 55% mixture. We'll get there though. And then we're doing the amount times the percentage. So X times 25 is just 25X. 1,000 minus X times 55, we're just going to set it up like distribution. 55 times 1,000 minus X. And then 1,000 times 30 would be 30,000. Let's write it like 1,000 times 30 right here. Or 30 times 1,000. So great, that's the hard part, filling out the chart. And then the equation's always going to be the same. It's going to be like mix 1 plus mix 2 equals the blended mix. So the amount of mix 1 is 25X. Mix 2, we have 55 times 1,000 minus X equals both. The blend would be the 1,000 times 30. And if you have a calculator, this shouldn't be too bad. We'll go ahead and distribute. So we'll have 25X plus 55,000 minus 55X equals 1,000 times 30 is 30,000. I have to sneeze, so I might need to pause here soon. If we combine our like terms, 25X minus 55X is negative 30X plus 55,000 equals 30,000. We'll go ahead and subtract that 55,000. Writing a lot of zeros here. Negative 30X equals negative 25,000. And then we'll have to divide by that negative 30. Now we're going to get a decimal here. It asked for an approximation. So I think, let's see, 25,000 divided by 30. It's 833.3 repeating. Let's just go ahead and call it 833. So if we look, that's the amount of mix 1, 833 milliliters. Mix 2, we have to do 1,000 minus that. So 1,000 minus 833 is 167 milliliters. So we could say 833 mil of the 25% mixture and 167 milliliters of the 55% mix. That was tough, man. I'm not going to deny it. That's a challenging problem. But once you do a couple of them and you get in the flow, it's not too bad. How much of an 80% nitric acid solution must be added to 175 grams of a solution that is 12% nitric acid to produce a 60% nitric acid solution? Let's see what we got. Let's fill out our chart. Let's call mix 1 the 80% and we'll call mix 2 the 12%, and then the blend will be the 60%. So what else do they tell us? Well, they said that it's 175 grams of that 12%er. And they're saying, well, how much of the mix 1 do you need to add? We don't know. Let's call it X. Now, if it's the blend, it's going to be mix 1 plus mix 2. So how do I write X plus 175? Just like that. X plus 175. Great. Now that third column, we're just multiplying the amount by the percent. So 80 times X is just 80X. 12 times 175, I'll just write it like that for now. And then 60 times the X plus 175. Great. So remember our equation now. It's mix 1, amount times percent, plus mix 2 equals the blend. So if we were to do that, we'd have 80X for mix 1 plus 12 times 175 is 2100 equals 60 times X plus 175. We'll go ahead and distribute that 60. 80X plus 2100 equals 60X plus 60 times 175, I don't know, 10,500. So obviously we'll want to get the x's on the same side at some point. I'm going to do it now. We'll just subtract 60x from both sides. That would give us 20x plus 2,100 equals 10,500. Great. It's a two-step equation now. Subtract the 2,100. 20x equals 8,400, and we're having fun. And we just divide by our 20. Let's see, we can knock off a 0. 84, 8 divided by 2 is 4, 2, 0. So x equals 420. So mix 1 is going to be 420 grams. And that's what they were asking for. So I guess that could be just our final answer. If they said how many grams are in the full amount in the blend, you would just have to do 420 plus the 175. But they didn't ask us that. They're nice. That would be 595 grams. They didn't even ask though. So that's it. We're going to try some of each of these 3 types of problems. You got it. I know you're going to be pros. I know this. Come on.